Okay, you guys, so we're ready for example number 10 and under linear functions. And so I just have to tell you, when my children were young, I'm an empty nester now. Yeah, story time, aren't you excited? When my children were young, Daddy used to take them to the Topeka Library to look for math questions for his class. Some dads would take their kids fishing. I would take my kids to look for math problems. And anyway, so I'm standing in the library in the math section at the Topeka Library, and I'm reading a book, and it mentions this question right here about how shoe sizes are related, obviously, to the length of the shoe. The bigger the longer the shoe, the bigger the shoe size, that kind of thing. And it turns out that there is a linear relationship, y equals mx plus b, between the size of a shoe and the length of the shoe. All right, now the two variables here again would be the shoe size and the length of the shoe. And so I was thinking, all right, if I'm going to define my variables, this is a word problem again, isn't it? And as I've been suggesting to you, when you're going to define your variables, think about the phrase y per x. Y per x. All right, that's a big word there. We're going to put that in a couple of these application questions on assignment 19. Look for it. Per! It's a big deal, all right? It's going to help you figure things out. So y per x. I can't say that enough. I hope I've emphasized that. So I'm standing there in the library reading this passage, which I have to admit I took from a book and didn't cite the source. Sorry. But right here, this caught my attention. It says, in the U.S., there is a difference of 1/3 inch per shoe size. Y per x. Inches per shoe size. So y would be the number of inches, and x would be the shoe size. All right? And I yelled that out at the library. Look at that, kids! Y per x! And my poor son was over in the corner going, Dad, they're going to kick us out of here again. Anyway, I couldn't help myself. Here's another thing that's really interesting about this. Not only do they have that per relationship there, but there's a number attached to it. 1/3 of an inch per shoe size. And that's going to make this question way easier if we recognize that, because look, a slope is 1 unit per, that's what a fraction bar is. There's the connection, right? Y per x, slope, y per x. If they give you a number, when they say 1/3 inch per shoe size, that is your slope. You don't have to figure it out. They gave it to us. I bet you there's a question on homework like this where they give it to you. Per! All right? And if they're kind enough to do that, take advantage of it. All right? This is the kind of question that just, it's supposed to be easy, and we make it more complicated than necessary. Look for it, look for it. On a quiz, on a homework, if there's a number attached to y per x, that's your slope. So finding the slope here.
That was easy. That was easy.
Yeah, it was doubly easy. Okay? 1/3. So you put 1/3 in there where the slope would be. They gave it to us. How cool. All right? So, can't say that enough. Can't scream it enough. All right. And by the way, we're doing part A. We're finding the linear equation that relates these two variables. All right. Now, when we talk about finding the value of b, we've talked about writing down the equation y equals mx plus b. This is detective work. M is 1/3. So here, and I'm serious, I'm standing there in the Topeka Library and I'm going, where in the world could I get an ordered pair at this point to stick in for the x and the y? Keeping in mind that the x would be a shoe size and the y would be inches. So I'm sitting there and I'm going, how in the world could I figure out an ordered pair, shoe size, inches? And I happened to look down at my feet and I was like, I'm wearing shoes. I'm wearing shoes here at the Topeka Library. And not only that, but I know that I wear a size 12 shoe. What's that smell? So that would be a value of x, wouldn't it? Man, it would sure be nice if I knew how many inches long my size 12 shoe is. if only I had something with me to measure my shoe. And look at that. I happen to have a meter stick in my back pocket, just in case I ever had to measure something, for example, my shoe. So I pulled out that meter stick. This is inches, so I had to look at the inches on it, and I measured it, and I found that sentence there on your printout is the shoe that I was wearing that day that I'm wearing today. Well, I'm not wearing it now. But anyway, a size 12 shoe I discovered by measuring with my meter stick that I always keep in my back pocket is 12¼ inches long. And so, that provides an ordered pair. So that observation came from the shoe on my foot. Isn't that exciting? Yay! All right. I've never given lessons in a t-shirt, shorts, a hat, barefoot, sock feet, whatever. Actually, whatever. Now, there you go. There's an ordered pair. So x would be 12 and y would be 12¼ Solve it. 12 over 1! Right? So you do this, and so 12¼ would equal 1/3 times 12, which is 4, plus b. Do the arithmetic. Subtract over the 4, subtract over the 4, and b would equal 8¼ And that's right there, 8¼ All right. So I'm standing there in the Topeka library, and I'm thinking, man, I built my equation based on the 1/3 inch they told me in that book and my shoe. And I was thinking, I wonder if there'd be a way to possibly confirm this equation. So I looked over at my son, who was still cowering in the corner, and I said, hey, you're wearing a man's shoe today, aren't you, son? And he's like, yeah. And I said, what size do you wear? He said, a 9. And I said, well, I would like to put your size 9 shoe in for x in my equation I just built, son, here in the library, and check it out, see if it works. Okay, so let's put 9 in for x, the size of my son's shoe at that time. Kid's got huge feet now. And anyway, this is years ago. And 1/3 times 9 is 3. And according to this mathematical model then, if you wear a size 9 men's shoe, it should be 11¼ inches long. So I said, hey son, give me your shoe. And he's like, right here in the library, Dad? And I'm like, yeah, give me your shoe. And he's like, really? Right here in the library? And I said, yeah, come on, I need to check my equation. Oh, okay. So he gave me his shoe, which interestingly looks a lot like mine. And when I measured his size 9 shoe with the meter stick I carry in my back pocket at all times in case I ever need to measure something, indeed, it was 11¼ inches long. So there's our outing at the library and how we found math. So, I don't know, Father of the Year, huh? Love you, kids.